Good afternoon, students. So, our today's topic for discussion is dissociation constant and its relation with pKa, and also we will discuss about Handerson Hasselbalch equation. Okay, so in the previous class we studied about dissociation constant. What are the other names of dissociation constant? Is also known as equilibrium constant. Okay, and it is represented as Ka. Okay, so the relation between dissociation constant and pKa is given as pKa equals negative log of Ka, just like that of what? pH. pH is negative logarithm to the base 10 of hydrogen ion concentration. Similarly, the pKa is equal to negative log of Ka. The pKa of a weak acid is the pH at which the acid is half ionized. Okay, it will be explained in detail while I discuss about Handerson Hasselbalch equation. Now, just study it. The pKa of a weak acid is a pH at which the acid is half ionized. We know that the dissociation constant is equal to concentration of H plus into concentration of A minus divided by the concentration of Ha, right? So, what will be pKa? pKa is negative log of concentration of H plus into concentration of A minus divided by concentration of Ha. Okay. So, pKa equals negative log Ka. Negative log of Ka. Here which is equal to negative log of H plus into A minus divided by concentration of Ha. Okay, which is equal to log of, just ulta varum, log of concentration of Ha divided by concentration of H plus into concentration of A minus. So what will happen if it is a strong acid? What will be the value of pKa? What will happen in case of strong acid? What will happen in case of strong acid? H plus ion concentration will be more. So here it is negative. So when we convert into the positive side, then it will be log concentration of Ha divided by concentration of H plus into concentration of A minus. So in the denominator there will be more concentration of H plus if it is strong acid. So what will happen to the value of pKa? The pKa will decrease. So when the H plus concentration increases, the pKa value will decrease. Correct. The strong acid will have low pKa and weak acids will have high pKa. Hope it's clear. So pKa is negative logarithm of H plus ion concentration into A minus concentration divided by concentration of Ha. Strong acids will have low pKa and weak acids will have high pKa. Next, about the effect of salt upon dissociation. So it is expressed by using Handerson Hasselbalch equation. It is given as pH is equal to pKa plus log of base by acid, or pH is equal to pKa plus log of salt by acid. So here, when the concentration of base and acid equals, the pH is same as that of pKa. So just remember what is the Handerson Hasselbalch equation? pH is given as pH is equal to pKa plus log of base by acid. Thus, when the acid is half ionized, pH and pKa have some same values. So consider a reaction in which the acid is half ionized. So the concentration of the product and the concentration of substrate will be equal. So the log salt by acid will be 1, and in log 1 will be 0, and so pH will become pKa. I will explain it later. So till now we discussed about the relationship between dissociation constant, the pKa, and also the Henderson-Hasselbalch equation. Next, let's see the derivation of Henderson-Hasselbalch equation. Now let's see the derivation of Henderson-Hasselbalch equation. Consider the reaction Ha gives H plus A minus. Okay, so what will be the Ka of this reaction? K is equal to concentration of H plus into concentration of A minus divided by concentration of H, right? It is same as that of Ka into concentration of Ha, which is equal to concentration of H plus into concentration of A minus. Till this you know the dissociation constant is written as constant of forward reaction by concentration of reverse reaction, which is equal to concentration of H plus into concentration of A minus divided by concentration of Ha, right? Then divide each side, both side, right hand side and left hand side, with concentration of A minus. Then we will get as concentration of H plus equals dissociation constant into concentration of Ha divided by A minus. Clear? Then substitute with log concentration of H plus equals log concentration of Ka into concentration of Ha divided by A minus. Clear? Convert both sides into logarithmic scale. Then log of concentration of H plus equals log of Ka into concentration of Ha divided by concentration of A minus. Which is same as that of log concentration of H plus equals log Ka plus log concentration of Ha divided by concentration of A minus. Then substitute with negative sign on both sides. Give a negative to this and then give negative to both sides. So negative log H plus concentration equals negative log Ka minus log concentration of Ha divided by concentration of A minus. So what is negative log H plus concentration? It is pH. pH equals, what is negative log Ka? It is pKa. pKa minus log of Ha concentration divided by A minus concentration. Okay, or it can be written as pH is equal to pKa plus log of concentration of A minus divided by concentration of Ha. Hope it's clear. So let's see the derivation once more. Consider the equation weak acid Ha equals H plus A minus. So here the dissociation constant is given as concentration of H plus into concentration of A minus divided by concentration of Ha. Which is same as that of dissociation constant into concentration of HA equals concentration of H plus into concentration of A minus. They divide the both sides by concentration of A minus. So we will get as log H plus is equal to log of Ka plus log of HA by HA minus. So minus log of H, substitute with minus sign on both sides. Minus log of H plus is equal to minus log of Ka minus log concentration of HA by concentration of A minus. We know that minus log H plus and concentration is equal to pH. So pH is equal to pKa minus log HA by A minus. Okay, so it is a derivation of Handerson-Hasselbalch equation. So what is the significance of Handerson-Hasselbalch equation? It has got some predictive value in protonic equilibrium. For example, what will happen when the acid is exactly half neutralized? That is, when concentration of A minus equals concentration of HA. In this case, the pH pH is equal to pKa plus log concentration of A minus divided by concentration of HA. Substitute this value in this equation, we will get what? pH is equal to pKa. So at half neutralization, pH will be same as that of pKa. This is what I told earlier. What pKa is the pH at which the acid is half ionized or half neutralized. Correct. And next significance is that what will happen when the ratio is that is the concentration of A minus by concentration of HA is 100:1. That is when the concentration of A minus, that is substrate concentration is A minus concentration is more when compared to that of concentration of acid. What will happen? In this case, pH is equal to pKa plus log of what? Log of 100 by 1. That is pH is equal to pKa plus 2. And what will happen if the ratio is 1:10? Substitute this value in the equation, we will get pH is 1 minus that of pKa. Okay, when the acid is half neutralized, pH is equal to that of pKa, and when the ratio is 100:1, the pH is plus 2 of pKa, and when the ratio is 1:10, the pH is 1 minus that of pKa. 1 minus of pKa. Okay. So in today's class, we discuss about the concept and relationship between the dissociation constant of the pKa and about the Handerson-Hasselbalch equation, how we derive this equation, and also the significance of this equation, that is, it has got a predictive value in the protonic equilibrium. Okay, hope it's clear. Thank you.